Our vision within Leatt in terms of all our products, but specifically helmets, is not only to produce a product that works well in terms of mitigating injuries, but is also lightweight and aesthetically pleasing. I mean, of course, you can have the best product on the market in terms of preventing injuries, but if it's not lightweight or comfortable to wear, nobody's going to use it. At Leatt, we look at the problem and try and fix the problem rather than just producing another product. And helmets are no exception to the rule. Our helmets are designed not just to pass a standard, but also to be effective over a wide range of impact velocities. We know that helmet test standards often look at traditionally 1 or 2 impact velocities. This is now increasing, thankfully, because I think it's better to test a helmet over more than 1 impact velocity so that manufacturers don't design a helmet to work extremely well on 1 impact velocity and not terribly well across a range. Previously, it was thought that brains were injured by just linear deceleration. In other words, your head is traveling, hits an object, decelerates, and that's the impact that the brain sees. We now know that it's actually rotational acceleration where the head impacts an object on the ground, for example, and starts rotating relative to the torso. And that rotational velocity is actually more damaging to the brain than just linear deceleration. Let me explain the 360 turbine technology that Leatt has introduced into its helmets. It's the small blue disc that you see mounted onto the EPS layer within the helmet, and that nestles within the comfort liner of the helmet. These little blue discs fulfill 2 functions really. The one is that they act as a linear low-speed damping system. So as the head compresses in an impact, these little blue discs, they decelerate the head in relatively low impact velocities, for example, 2.5 meters per second. And it's these repetitive low impact that riders may have more of during their career that we're trying to damp. The rest of the helmet is structured and designed to cater for more high-speed impact damping. But the turbines just add a wider range of impact attenuation so that in terms of reducing head and brain injuries, we can reduce traumatic brain injuries, of which there's a spectrum from concussion to really a significant brain injury that can cause death. The way the turbine works, not only to reduce that linear low-speed damping, but because it has a spoke and it's a round disc shape, it can be distorted in any direction relative to the EPS layer during an impact. So with rotational acceleration, those little blue discs, the 360 turbines, will be displaced and decelerate the head in a controlled way to mitigate against this rotational acceleration that can be so damaging to the brain.
So EPS is the foam liner inside of the helmet, and that's basically expanded polystyrene. And that's widely used across all bicycle and motorcycle helmets. What makes ours special is the fact that there's 4 different densities of EPS, which means the helmet is safe at high and low impact speeds.
If you look at a motorcycle or motocross helmet, it's typically an outer shell. It can be a plastic injected shell, a composite shell, or carbon shell. And that is manufactured separately from the impact liner, which is normally made from EPS. These 2 pieces are then put together. The EPS is glued inside the helmet shell, and that gives you a typical construction of a motocross helmet. If you look on the bicycle side, normally a bicycle helmet's shell is a lot thinner. That allows that piece to go inside the mold. The EPS is then injected directly into the shell, and it's called in-molding, and the 2 are bonded in the injection process. Our new helmet basically uses a standard shell and EPS that are glued together. Obviously, our helmet is now typical in size to what you see in the market. One of the things that allowed us to have this helmet that performs well in impacts is that we're using a few pieces of EPS. All of these different pieces of EPS, the densities can be set or changed per piece of EPS. This allows us to get a good balance in the helmet and allows us to have optimal impact performance no matter where this helmet is impacted.
At Leatt, we are lucky enough to have an ECE standard helmet test rig, which allows us to replicate the same type of tests that are done in order to pass test standards. We can replicate Snell, DOT, EC tests, as well as do some rotational acceleration testing, which gives us a really great basis for not only product development, but also prior to sending our products off for standardized testing for homologation, we can understand what the results are going to be.
If you look at our helmet, the weight in the end, for a DOT helmet, our helmet weight is very good. So the current ECE standard is 2206, which is the new standard. This standard has many more impact points. It's got high speed, low speed, and they've introduced rotational testing. During the development of this helmet, we knew where it was going. So from the start, we worked on this new helmet of ours to make sure that we will pass the new standard. FIM also does a helmet standard for road use of helmets, especially for MotoGP and these things. We've tested our helmet to the FIM road helmet standard, and I can tell you now that we've also passed these impacts with flying colors.
What we did with this helmet is we put a massive air vent just above the brow, which allows air to get in. Then there's EPS channels on the inside, just between the liner and the EPS, but also between the multiple different densities of the EPS. So you've got ventilation going all through the helmet. And then at the top, we've got another 2 vents, which we call the low-speed air vents, which means that while you're standing still or riding at low speeds, there's enough ventilation. It's quite a big hole in the EPS, which is a challenge in itself, because you have to pass DOT, and there's a big, massive spike hitting that vent. So to pass that standard was quite difficult.
For us, helmet weight is, we've always said that we want to have a light helmet. This will help with rider fatigue, because a lot of these events are already tough on the body and you don't want to strain the neck unnecessarily. We wanted to obviously make our helmet as comfortable as possible. So one of the things we came up with is that we looked at what's in the market there, and a typical comfort liner of a motocross helmet or bicycle helmet for that matter is a single piece of comfort liner, which is the fabric and the foam that are all stitched together. So what we decided is to break it up into separate pieces. So we've got the top pad and the crown pad and everything going around, and all these pieces are connected with elastic bands. When you put the helmet on, you put this liner on your head, it basically forms to your head. So you've got a bigger head, it will stretch. You've got a smaller head, so it will shrink. And in the end, what that allows us to have a very comfortable, very well-fitting helmet.
Whether it's our neck brace, our goggles, our helmet, our knee braces, we look at what we believe is the best answer to the problem and then innovate around that. And our mantra, science of the thrill, is really about producing the science that makes the product effective and allows the athlete to continue with their sport.
For more information on the products listed in this video, click on the link in the description area below. Feel free to call us with any questions or place an order at 800-969-7501. Don't forget to smash that like button, comment, share, and subscribe for all of the latest DK events, videos, and promos.